A very warm welcome to all students. So today we are going to spend some time on a new topic, semantic analysis. If we see from the point of view curriculum, we are going to start unit number 3rd. In classroom teaching, we have covered almost 2 units. First unit was introduction of compiler, lexical analysis, and second unit is nothing but syntax analysis, various parsing techniques we have seen already. So semantic analysis, this is the first very important phase and the last very important phase of backend compiler design. As you have seen, compiler design has two phases, two major phases, which I'll say front end and back end. So in front end we have three phases: lexical analysis, syntax analysis, and semantic analysis. So today we are going to discuss semantic analysis. These are the topics which we will cover in this presentation, this video, whatever you say. Semantic analysis, the first topic, a role of semantic analysis and its responsibilities for compiler. The third important topic is evaluation of a parse tree containing synthesized and inherited attributes. Means always semantic analyzer always evaluates the parse tree because it converts a parse tree into annotated parse tree in two manners: synthesized as well as inherited attributes. So let's get start with semantic analysis. If we see before the definition of semantic analyzer, these are the figures separated by a thick line. And first figure, the input of semantic analyzer is production rules and output of semantic analyzer is semantic rule. Now what is the production and what is the semantic? As we know, a semantic analyzer is nothing but just used to check the logical meaning of a given expression. Let me do one thing very clear to you. In lexical analysis phase, the scanning of code is done, and in syntax analyzer phase, the syntax of given string, given expression, given piece of code is checked by the syntax analyzer through parsing, which may be top down, which may be bottom up. And in semantic analyzer, when a statement is lexically correct, syntactically correct, it check for semantic. The semantic means, let us suppose we are going to declare an array of size, let's suppose 50, and next time we are accessing this particular array 53rd element. So lexically there is no problem, syntactically let's suppose there is no problem, it is declared as per the rule, but semantically there is a problem, there is a logical problem. What the problem is, we have given the range, static range you will see of an array is, let's suppose 50, it can store 50 elements max, and we are retrieving 52th elements. So these kind of errors are encountered using semantic analyzer phase. Another thing is, semantic analysis is the phase, last phase of front end of compiler. After that, compiler enters back end phase. So this is very important phase of compiler design. Now see, come to the topic, semantic analyzer. Now this slide, The first figure is production and semantic rules. If you have seen, there are some production rules. Let's suppose E generate E1 plus T, E generate T, T generate T1 multiplication, and T generate F, F generate open and close parenthesis E, and F generate DZ. Now, on another hand, we have semantic rules. So, what is the difference between these semantic rules and production rules? So, as we have seen in earlier lectures, so production rules is what actually? This is a part of grammar which we have used in parsing. So let's suppose my first production rule is E generate E plus T. Let's suppose E generate T, the second one. Third one is T generate T multiplication. Now fourth one is T generate F, and next one is F generate open parenthesis E close parenthesis. And the last one is F generate digit. This is the well-known grammar we have seen in earlier lectures, classroom teaching during class. So the productions are we have seen already. Now, how the production is get converted into semantic rules. See, if we associate the attribute values with respect to every production, then it becomes semantic rules. How? Now the first production is E generate E plus T. So its semantic rule will be E dot val, means the value of E is in an attribute and is associated with E, is equal to E dot val plus T dot val, which means in production we have used two variables E and T, and every variable is associated with value, and value is a attribute. Now what the problem will be in this expression? When this production is get you know uh, converted into decorated parse tree, it will look like E dot val generates left child E dot val separated by plus, and right child is T dot val. Then if we see very closely, then the left child and the root are same, which is not feasible, right? So that's why we distinguish E and E. So left hand side production rule is E generate E1 plus T, and right hand side is E dot val is equals to E1 dot val plus T dot val. Every variable is associated with attribute, and attribute is value over here. So similarly, next production is E generate T. So E dot val is equals to T dot val. And next production is T generate T1 multiplication F, and the semantic rule is T dot val is equals to T1 dot val multiplication F dot val, and so forth. And finally F generates, the last is F generate digit. So how it will look like? F dot val is equals to digit dot lex val, which means a digit dot lex val is any lexical value during the lexical phase which was stored in symbol table, and now it is retrieved from the symbol table and get placed on F dot val. And second figure, a parse tree will be an input for semantic analyzer, and the output of semantic analyzer is annotated parse tree, right? So if we see very closely, so our grammar is D generates TL, T generates real, float, char, int, and L generates L comma ID, and L generate ID. So this is the grammar basically. This grammar is mentioned in a whole man also. Now this is the input for semantic analyzer here, and the output is D generate T. So T dot type is equals to real, which means T is a variable which type will be real. So this is the attribute which is associated with T, and T is generating real also. Right hand side, because D is generating T as well as L. So L is generating L dot in is equals to real, and L is again generating L1 dot in is equals to real comma identifier. Now further this L will be generate L dot in is equals to real comma ID2. Now the last one in this figure, L1 is only generating ID1. Why? Because if we see left hand side, our input is real P comma Q comma R. So I need only three identifiers. That's why L is ended by a single identifier. So here, if we see an annotated pass tree, what is the difference between annotated pass tree and pass tree? An annotated pass tree is always contains attributes associated with every production symbol. The symbol may be variable, may be terminal. Now there is a question in semantic rules. If I generate the semantic rule for D generate TL and T generate real, L generate L comma ID and L generate ID. Here the T dot type is real and above E dot well. So what the situation is, in upper diagram E dot well and in lower diagram T dot type. So dot type dot well, what are they? They are attributes. Attributes are majorly of three types. It may be any value, it may be the type of that particular variable, it may be the address of that particular variable. So if value, then variable dot val. If there is an address, then variable dot ptr, pointer variable. And the third thing is type, then variable dot type. So this is the convention. So semantic analyzer always takes input a pass tree and always converts this pass tree into annotated pass tree. Now this annotated pass tree is a further treated as an input for the next phase, which is intermediate code generation. Now semantic analysis. So here we'll see what the semantic analysis once again, its roles and responsibilities. So as we know, it is the third phase of compiler design and the last phase of front end of compiler, right? So semantic analyzer is responsible for computing the semantic definitions for every declaration and statements of a program. The third rule says what? Semantic analyzer is a collection of procedures, collection of rules, which is called by parser as and when it is required by grammar set of rules. And next point is what? Semantic analyzer always take help of a data structure which is maintained by compiler known as symbol table. Why symbol table is used? Because the very important role of semantic analyzer is type checking. And type checking is what? The checking the data type and typecasting, type conversion is the responsibility of, under the type checking for semantic analysis. Let's suppose if I have a variable and it has certain value, it may be in integer, it may be a float, it may be a character, it may be a literal value. So during the first phase lexical analysis, every literal is gets stored in symbol table, and now for during type checking, semantic analyzer borrows these values from symbol table and check it type. Let's suppose I have two statements. The first one is x is equals to 2. 2 is equals to x. Which one is correct? Obviously, first one is correct. X is equals to 2. Why not 2 is equals to x? Because we all know a number cannot be on left hand side. This is a responsibility of semantic analysis. These are the logical rules that are checked under semantic analyzer phase. Another important role of symbol table during semantic analyzer is adding information. Adding information to each and every variable which is used into a grammar. Got it? So these are the responsibilities of semantic analyzer. As we know, type checking, it ensures the data types are used in a way consistent with their definition. Like if you declared a variable integer and you are calling this variable uh, other than integer, then there will be a problem. Label checking, least but not last, flow control check. Flow control means the flow control of every program is ensured by semantic analyzer. For example, a good example is given over here. No break statement is allowed outside a loop, which means whenever a loop is executed, no break statement is allowed. And the semantic errors which are encountered by this error handler is type mismatch. Type mismatch, again, when we declare a variable like integer and we are calling it other than integer, this is a type mismatch. You declared something and you're calling other, different, both are different. Undeclared variable, you are using a variable which was not declared earlier, or you are you are using a declared variable in other meaning. A reserved identifier misuse, which means a identifier is a reserved keyword and you are you are using in another ways, that is not up to the mark. Let's suppose you are using array which is size is 50 and you are calling its 52th element. This is the comes under semantic error. Array index out of bound in Java, you're familiar with it. So these kind of responsibilities are performed by semantic analyzer. SDT, syntax directed translation. So syntax directed translations are what? See, by syntax directed translation we indicate those formalism by specifying translations for programming language construct guided by context free grammars. As we have seen in earlier slides, context free grammars are used you know attached with attributes as well as some rules. So this you know whole way is called as SDT, syntax directed translation. Means we must have, if we have certain translation directions with the context free grammar, then this is known as syntax directed translation. Syntax directed translation is built by using or by by including attributes and semantic rules. Attributes may be already discussed, it may be type, it may be address, it may be value, and it becomes semantic rules next time. Next is SDD, syntax directed definition. There is a difference between syntax directed definition and syntax directed translation. In translation, there is a role of context free grammar where attributes are attached with CFG by making sense of semantic rule. In SDD, each and every variable as well as terminal must be associated with its definition. Then it becomes semantic rule. So this is the example of semantic rule. Here, if we see every production, let's suppose T generate F. So T dot well, which means T is associated with its value and F is associated with its value. So this is whole what? This is syntax directed definition. Every the grammar syntax is directed by its definition, and this definition is called as semantic rule. So SDD is computed or built by two ways. Number one, synthesized attribute, inherited attribute. Both are different. Which means if we have an annotated pass tree, now how the semantic structure is built? The semantic structure is built by using semantic definitions, by computing syntax directed definition, and the syntax directed definition is computed by synthesized attribute. So synthesized attribute says what? Synthesized attribute are computed from its child nodes, which means let's suppose we have e dot well is equal to t dot well. Now how it is looking like? E dot well generate t dot well. So the value of e dot well is computed by t dot well. Means if the attributes are computed by its child node, then it is synthesized attributes. Let's say this is the example of synthesized attributes. Synthesized attribute depend only on the attributes of children. So here A is generating B, A is generating C, and A is generating D. So A dot T means its attribute, B dot T1, C dot T2, D dot T3. So the rule is saying what? The definition of A is only depends on either on B or C or D, which means synthesized attribute are totally depends on the value of its children. Or in another way we can define the attributes that depends on the attributes of its children is called as synthesized attribute. This is a synthesized attribute. And the definition of synthesized attribute is if each production A generate alpha is associated with a set of semantic rules. So B is equals to F C1, C2, and so on and so forth Ck, where F is a function and either. So synthesized attribute of A, B will be its synthesized attribute, and C1, C2, and so on Ck are attributes of the grammar of the production. Okay, if and only if the production will look like A generate alpha. This is the mathematical formula to computing synthesized attribute. Next one is inherited attributes. Its name is inherited. So inherited attributes are incorporated from the values of the attribute of both sibling and parents. What does it mean? It means if and only if an attribute is computed from its sibling node or its parent node, then these attributes are called inherited attributes. Let's have a look. So this is the example of inherited attribute. An inherited attribute is defined in terms of its parent node or its sibling node. Let's suppose we have B generate A, C and D. So B dot T1 its attribute, A dot T its attribute, C dot T its attribute, D dot T3 its attribute. Now let's suppose I want to compute the definition of A. So A dot T, if A dot T is computed from either C or D, those are the sibling of A, remember, or from B, which is parent of A, then this definition is called as inherited attribute definition. You got it or not? So this is very simple. So this is the mathematical way. B is an inherited attribute of a grammar symbol in alpha, and C1, C2 and Ck are attribute of a grammar symbol in alpha or attribute of A. So this is about the syntax directed definition. There is a note given. Terminal symbols. Yes, terminal symbols are assumed to have synthesized attributes supplied by the lexical analyzer. This is true. If we have any terminal symbol, then definitely by default it is treated as synthesized attribute. Why? Because टर्मिनल सिंबल से ही इंफॉर्मेशन बॉटम से टॉप में जाती है, ना कि टॉप से बॉटम में जाती है. लेट्स सपोज आई हैव अ प्रोडक्शन ए जनरेट आईडी where a is a variable, id is a terminal. So a generate id, which means a dot well is equal to id dot lexwell. तो id डॉट लेक्सवेल की जो वैल्यू है वो ट्रांसफर की जाएगी a डॉट वेल में, ना कि a डॉट वेल की वैल्यू ट्रांसफर की जाएगी लेक्स डॉट लेक्सवेल. दैट डज इट मीन्स. सो बाय डिफॉल्ट a terminal symbol always play a role in SDT in synthesized form. So in this video we discuss the third phase of compiler design known as semantic analyzer, how it uses symbol table. With the help of symbol table, how perform semantic analysis during the compilation process, its roles, its responsibilities and attribute definitions while using synthesized as well as inherited attributes. In next lecture video, I will discuss two attribute values, synthesized L attributes and S attribute definitions. Through this L attributes and S attribute definition, we will see how an annotated parse tree will be compute semantic rules. Thank you.